In this video, we're going to look at frequency distributions and group data. So frequency distribution is really a frequency table. So anything that would have data value, so it could be height or age, and then a frequency, and that's what we mean by a frequency distribution. And these can be grouped or ungrouped, so we could have heights. So if they were ungrouped, we might have heights of 5, 6, 7, 8, whereas grouped would maybe be looking at 5 to 10, 10 to 15, and so on. Now, to work out the mean from a frequency distribution, we use this formula sigma fx, which is the sum of all the f's multiplied by all the x's, divided by sigma f, which is the sum of f. The mean cannot be calculated in a grouped table because if we've got a group of 5 to 10, we don't really know what values they take, whether it's 5 or 6 or 7 or whatever it might be. So we can only work out an estimate, and we do that by taking the midpoint of the group as our x value. So whenever we're multiplying our frequency by our x values, in the case where we've got exact values of 5, 6, 7, or 8, those are our x values, but if we've got 5 to 10, 10 to 15, we use the midpoint as the x value. To find the median, we calculate the running total and identify where the middle term is. The median can't be calculated in a group table, again only an estimate because we don't know the actual values. And in the case of grouped tables, we might use n over 2 or n plus 1 over 2, whatever is easier really, will get us what an estimate for the median is going to be. The modal term or group will have the highest frequency, and the range is the largest group value minus the smallest group value. So example 12, find the mean, the median, the mode, and the range of the data below. So we've got our frequency values and our x values, and to work out the mean, that's sigma fx divided by sigma f. So we need to work out an fx column, and remember that's just f multiplied by x. So we'll do 4 times 3 is 12, 6 times 8 is 48, 11 times 8 is 88, 8 times 10 is 80, 12 times 4 is 48, 6 times 14 is 84, 8 times 16 is 128, and 2 18s are 36. So we've got our fx values. We now need to work out the sum of fx and the sum of f, and that's found by adding the frequency values and the fx values. So the fx's all add up to 50, and the sigma fx add up to 524. So to work out the mean, we'll divide 524 by 50, and we get 10.48. To work out the median, we need to work out the middle number. Now we know there's 50 terms. Now because this is not group data, we have to use n plus 1 over 2. So it's going to be 50 plus 1 over 2, which is the 25th and a half term. So to work out where that is, we need to look at the cumulative frequency, and that's the running total. So there's 3 in the first group, there's 8 in the next group, which means that as total there's going to be 11. Another 11 takes us up to 22nd term. 8 is 30, 34, 40, 48, and 50. So what we know is that the first 3 terms are in 4, and then the 4th, the 5th, the 6th, up to the 11th, they're all 6s. Then the 12th, the 13th, the 14th, up to the 22nd term are 8s. The 23rd, the 30th are all 10s. The 31st, the 32nd, the 33rd, and the 34th term are all 12. The 35th to the 40th are all 14s. The 41st, the 42nd, up to the 48th are 16th. And the 49th and the 50th term are 18. So if we're looking for the 25th and a half term, we know that the 22nd term is an 8, and then the 23rd is a 10. So the 25th term is also going to be a 10, and the 26th is also a 10. So we'll do 10 plus 10 divided by 2. Because it's 0.5, then we need to find the average of the 2 points, and we get 10. So the median is going to be 10. The mode is the most popular, it's the highest occurring, the most frequent. And we can see that with a frequency of 11, 8 is the highest value. And we give the x value as the mode, not the frequency value. So it's 8, not 11. So 8 occurs 11 times, so that's the value. In part D, the range, so the highest value is 18, the smallest value is 4, so 18 minus 4 is 14. Our next example shows the frequency distribution, and we've got its group this time. So what we need to do is work out the midpoints, and there are x values. So the midpoint of 0 to 4 is 2, and 4 to 8 is 6. 8 to 12 is 10. The midpoint of 12 and 16 is 14, and 16 to 20 is 18. We need an fx column, so that's multiplying frequency by our x values. So 13 times 2 is 26. 32 times 6 is 192. 17 times 10 is 170. 10 times 14, 140. 8 times 18 is 144. And adding these together, we get 672. Now that's needed for the mean, which is the third part. So the first part for the modal class, that's the one that occurs most frequently. And we can see with the highest frequency of 32, the modal class is 4 up until 8. To work out the median class, that's the middle class, it's the one with the middle value. Well, we know that there's 80 terms, so the median is going to be 80 over 2, which is the 40th term. So if we work out the cumulative frequency, we know in the first group there's 13, the next group there's 32, which takes us up to 45. 17 more is 62, and then 10 is 72, and our last 8 is 80. So if we're looking for the 40th term, the second group has the 14th, the 15th, and all the way up to the 45th. So then the group which will have the 40th term is 4, which is less than L, which is less than or equal to 8. Part 3 then, to work out an estimate of the mean, we're going to do the sigma fx divided by sigma f, which is 672 divided by 80, which is 8.4. So the estimate of the mean is 8.4 centimeters. Example 14, find n if the mean is 4.525. So what we know is that mean is sigma fx over sigma f, and that's going to equal 4.525. So if we work out an fx column, we're going to have 2 times 6 is 12, 3 times n is 3n, 4 times 5 is 20, 5 9s are 45, 6 4s are 24, and 8 7s are 56. And if we work out the sum of f, we're going to add 6 and n, and 5 and 9 and 4 and 8, which is 32 plus n, and adding our sigma fx's, so 12, 20, 30, 45, 24, 56, and 3n, we get 157. So therefore 157 over, or 157 plus 3n, sorry. So 157 plus 3n over 32 plus n is equal to 4.525. So if we multiply up by the bottom, we get 157 plus 3n is going to equal 4.525 upon 32 plus n. So 157 plus 3n, if we expand out the bracket, so multiply everything inside the bracket by the 4.525, and we get 144.8 plus 4.525n. Now bringing the n's to one side, so we'll bring the 3n over, and we'll also bring the 144 across, and we're going to have 1.525n is going to equal 12.2, and dividing by 1.525, we get that n is equal to 8. So the missing value was 8. Example 15, calculate the mean spent by men, women and teenagers on a weekend break. So what we've got is the amount is going to be our x value, and the people is going to be the frequency. So if we've got fx, we need to multiply those two together. So we'll multiply 8 and 184.64, and we get £1,477.12. 9 multiplied by 157.58 gives us £1,418.22, and 3 teenagers who spent £79.48 gives us a total of £238.44. So our sigma f, 8 plus 9 plus 3 is 20, and our sigma fx is 3,133.78. So the mean, which is sigma fx divided by sigma f, is 3,133.78 divided by 20, which gives us a value of £156.69. Now, when we're looking at range, which is the biggest value minus the smallest value, this is drastically affected by extreme, so very high or very low values. So the measure of spread that goes with the median, which gives us which isn't affected by those extreme values, is the interquartile range, which is generally a better measure of spread. Now the median is halfway through the distribution, and quartiles will hopefully be no surprise that it's going to be 1/4 and 3/4 of the way through the distribution. So the interquartile range is going to be the difference in those. And generally we talk that the smallest value is our Q0, Q1 being the lower quartile, Q2 is the second quartile or the middle quartile or the median, Q3 is the upper quartile, and Q4 is the largest value. So range, we're talking about Q4 minus Q0, but interquartile range, the difference in the quartiles, is Q3 minus Q1. And it's useful to think that the difference between the smallest value in the lower quartile is 25%. It's 1/4 of the distribution. Between the lower quartile and the median is 25%. And the median in the upper quartile is another 25%, and the upper quartile and the largest is also 25%. So the interquartile range looks at the middle 50% of the data. Example 10, find the median quartiles and interquartile range for this list of data. And what we should do with this, whenever we're working out the median, and it's the same for the quartiles, we need to order this from smallest to biggest. So we can see that there are 2 4s, and then we've got a 5, and then we've got a 6, and then 3 8s, 2 9s, 3 9s, sorry, third 9 there, and then a 10 and a 12. And we can check that we've got 1 2 3 4 5 6 7 8 9 10 11 12 values. 1 2 3 4 5 6 7 8 9 10 11 12. So we've not forgotten one. I almost forgot the 9, but we didn't. So there's 12 values, so that means that n equals 12. So the median, which is Q2, is n plus 1 over 2. 12 plus 1 over 2, which is the 6.5th term. So we're going to look between the 6th and the 7th term. So 1, 2, 3, 4, 5, 6, and 7. So the median is going to be between the 6th and the 7th term. So it's going to be 8 plus 8 divided by 2, which is 8. The lower quartile is n plus 1 over 4, which is 12 plus 1 over 4, on the 3.25 term. Now for this, we still look at the third and the fourth term and look halfway between those. Although it's 1/4, we still just go halfway. So the third is the 5, and the fourth term is the 6. So we'll do 5 plus 6 divided by 2, which is 5.5. To work out the upper quartile, let's say n plus 1 over 4 times 3. It's 3/4 of the way through. So that's 12 plus 1 over 4 times 3, which is the 9.75th term. So again, we're going to look at the 9th term, the 10th term, and go halfway between those. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're between the last two 9s. So we 9 plus 9 over 2, which is 9. Now we could have done this differently. So rather than working out n plus 1 divided by 4 times by 3, because we know the quartile is the 3.25 term, we could have counted back 3.25 and looked at the third and the fourth term. So 1, 2, 3, 4. So it's the same two 9s. So it doesn't matter if you count forwards or backwards, or do n plus 1 over 4 times 3. The interquartile range then is the upper quartile minus the lower quartile, which gives us 3.5. So we've looked at working out the median and the quartiles from the frequency table, the median and quartile group. Now we can look at working out an estimate for the median value or a quartile. So we don't know the exact value, but we can only find an estimate. And the way that we use this is interpolation. And interpolation is really looking at whatever fraction of the way into a group that we need to go. So we can see that this group has 25 in it, and it's 20 wide. So if we were looking for 10 terms in here, what we kind of do, or what we think about, is that the group is 20 wide. So we divide the width by the 25 terms, and we multiply by the number that we need. And that gives us the fraction of the way through. So what we're really assuming is that the frequency, so the 42 terms, would be evenly divided across the group that's 20 wide. So if we divide the frequency into the width, and then we multiply by the number we need, and that will give us how far into a group we need to go. And then we add that to the lower bound to get the specific value, or the estimated value. So in this case, there are 100 pieces of data. So the median we know is going to be 50th. So here, remember, we're going to use n over 2. We could use n plus 1 over 2, but because it's even and because it's grouped, we can just do n over 2. So it's the 50th term here. From the table, that's going to be in the 20 to 40 group. That's because, well, we could work out the cumulative frequency. So 42 plus our 25 is 67, plus 9 is 76, plus 8 is 84, and plus 16 is 100. So the 20 to 40 group has the 43rd, the 44th, and all the way up to the 67th term in that. So because there's 42 terms already happened, the 50th term is going to be 8 in here. So to get from 42 to 50, we'll add on 8. So we need 8 of this group. So what we'll do is we'll divide the width of 20 by 25, and then we multiply it by 8. And then we add that to the lower boundary, and we get £26.40 in this case. So this is set out slightly differently, but it's the same thing. It's working out the fraction of the amount. So the fraction that you need is 8 out of the 25. So you need 8 into the median, or into the group, out of 25, so it's 8/25, and then multiply by the width. So if we look at this example, we've got trying to work out the median and the two quartiles. So let's work out our cumulative frequency. So it's going to be 3 plus 10 is 13, plus 13 is 26, plus 25 is 51, plus 9 is 60. So the median, which is n over 2, is going to be the 30th term. The quartile, which is a quarter of the way through, is going to be n over 4, so that's 60 over 4, or the 15th. And the upper quartile is going to be n over 4 times 3, which is the 45th term. So let's work out the median. It's the 30th term. and we can see that there's 26 up to the end of 150. So the 30th term is going to be 4 into this group. So we have a 26 before now, and then we need 4 more terms to get up to the 30. So to work out the median, it's the lower class bound, which is 150 for this group, plus the fraction that we need. So we need 4 out of the 25, and we multiply that by the class width. And the difference between 150 and 160 is 10. So we'll multiply that by 10. Or we've got a width of 10. We've got 25 different pieces in there. So we divide the 10 centimeters by 25, and we multiply by 4. So we're doing 10 divided by 25 times by 4. It's the same thing. And if we add that on to 150, we get the median to be 151.6 centimeters. The lower quartile, what we can see is it's the 15th term. And the first 2 groups take us up to the 13th. So to get the 15th, we need 2 more in the 140 group. So the lower boundary is 140. We need 2 out of the 13 that are in that group. So we need 2 terms out of the 13, and we multiply that by the width of 10. And if we work that out, we get that the lower quartile value is 141.54 centimeters. And then the upper quartile is the 45th term. And the 4th group takes us from the 27th term up to the 51st term. So to get from 26 up to 45, we're needing 19 terms. So the upper quartile is the lower boundary of 150, plus we need 19 out of the 25, and multiply that by the width of 10, and that works out to be 157.6 centimeters. So those are our approximate values using interpolation, which is the fraction that we need of the width added on to the lower boundary.